In this example, we're going to solve over the domain 0 degrees to 360 and then also 0 to 2 pi. It says as appropriate, but we really don't know which degree or radian measure we should use, so we'll list both. Let's do the degrees first. So the sine of theta is equal to negative 1/2. You could easily type this in your calculator, and your calculator is going to spit out a value. Let's make sure we're in degree mode. And then we'll do the inverse sine of negative 1/2 or 0.5 and hit enter. We're given negative 30. Negative 30 here does not work in this domain or the values for theta, so we could just add 360 and that'll give us another one. So that's 330 degrees. 330 degrees is one of them, but there's also another angle that has a sine of negative 1/2. If we take a look at where this angle is, 330 degrees would be right here. This angle forms a right triangle with a y value of negative 1/2 if the radius is 1. We want to look and see on the coordinate plane, is there another angle where that happens? Notice that the reference angle for 330 is 30. We want the sine to be negative 1/2, so the sine is positive in quadrants 1 and 2. So we're going to look here in quadrant 3. And so in quadrant 3, we've got another angle that has the same reference angle, and that y value here, or the opposite side of that triangle, is going to be the exact same thing. So if you're wondering what that angle is, all we need to do is go around 180 and add 30 more. So that angle is 210 degrees. If you do the sine of 210 in your calculator, you definitely get negative 1/2. So we need to list both of these values. We can also change these into radians if necessary. That's fine too. So this one's going to be 210 is 7 pi over 6. You can multiply by pi over 180 if you want, if you're having trouble figuring out what these are. And the next one should be 11 pi over 6. So these are the same angles, 210 and 7 pi over 6 and 330 and 11 pi over 6, just using degrees on the left and radians on the right. It's like measuring something in meters or feet. The size of whatever you're measuring doesn't change. It's the way we're looking at it, or the unit, I should say. Let's try the next one. The cosine of theta is root 3 over 2. And we can use a unit circle approach, or you can use your calculator, either way. What we're looking for here is we're looking for a positive cosine. The x value needs to be positive, so that wouldn't be here, wouldn't be here. We're looking for two angles. One is in the first quadrant, one's in the fourth quadrant. And we want this adjacent side to be root 3 over 2. So these are the two angles right here. Oops, should be like that maybe. Continue this on a little bit. And we're wondering what those angles are. And these angles are actually the same between the x-axis. We want to state this angle as being from the positive x-axis. But anyways, this is a 30, 60, 90, where this one's 30. If the radius is 1, then this would be 1/2. The other side is root 3 over 2. So we know one of our angles is 30. That's kind of a goofy 30. It looks like 3 and 0 degrees, so let's rewrite that. Let's go 30 degrees. And then the other one, if this angle is also 30, we would come around to 360 and back up 30, and that would be 330 degrees. Writing these in radian measure, we're going to have pi over 6 and then 11 pi over 6 for these. Alright, let's try the same thing with the next one. You can use your calculator to investigate this, but definitely we're looking for y over x, and the y is the same as the x. And so the only triangle that's really going to work here, or an initial one that we could look at, is, that's not a very good 45, 45, 90, but that's supposed to be a 45, 45, 90. So this side is root 2 over 2. This side's root 2 over 2 when the radius is 1. So we've got root 2 over 2 over root 2 over 2, which is 1. So we're looking for that angle measure. Theta is an angle. The angle's 45 degrees. There's another angle where down here, where the same thing happens, but the x is negative, so that's negative root 2 over 2, and the y is also negative. I'll try to move this over if you guys can't see that. Hopefully that's good enough. So if a negative over a negative is still a positive 1. The situation that we don't want when the tangent is positive for the x to be negative and the y to be positive, or for the x to be positive and the y to be negative. So we know we're not going to be in quadrant 2, and we know we're not going to be in quadrant 4. This angle has the same reference angle, but we want to state it from the positive x-axis, so we're going to take 180 and add 45, and that's going to be 225. In radian measure, we've got pi over 4 and 5 pi over 4. The next one, we want the sine to be negative 1, so we want the y value to be negative 1. This point right here is 0, negative 1, so this angle measure is the one we're looking for. And so for this angle measure, what we need is 270. With the rest of these, they each had 2 angles, but this is a special one. When that point lies on a quadrant, lots of times you're only going to have one angle that meets those demands, especially if it's sine or cosine. And for the sine, it's going to be 90 here or 270, or for the x, it would be here at 0 or at 180, and that would be 1 or negative 1. So anyway, 270 is the only angle that meets this criteria, and 270 degrees, of course, is 3 pi over 2. And then if whatever problem you have, you can list either 1 degrees or radians.